there and welcome to this month's edition of In the Labs and me, Becky, and I'm going to show you how to create this beer flight. So let's take a look at the project files. Okay then, so let's open up the files. So in your project folder, you're going to have access to two CRV files. One is the beer flight inlay and tests, and two is the beer flight. So we're just going to take a look at the beer flight to begin with. Now I've already created all the vectors and the toolpaths for this. I'm just going to talk through how I created it, why I did, what vectors are for what toolpaths, just so you get an idea of what we're going to be machining. So to start with, we have this outer rectangle. Okay, so this is going to form the main profile shape of our beer flight. It's 17 inches wide and 6 inches high. Inside we've got a vector that's been offset by 1/2 inch, and this vector we're going to use to create a moulding toolpath where we're going to take this profile here and basically going to run that along the outside of the vector using the moulding toolpath to create a nice 3D edge around our part there. Then you'll see we have 4 circles. So what I've done is I've carefully drew around the base of a pint glass just to get a rough idea of the dimensions, and here you can see I've got a circle that is 2.8 in diameter. Now if you're going to cut this, then please make sure that you check the diameter of the base of the glasses that you plan to use and then alter these circles accordingly. However, I am still going to do a test to ensure that my glass can fit into the actual pocket itself. Okay, so we're going to pocket these vectors down just to give it a nice little area for the glass to sit in. Then underneath, you can see we have a series of rectangles. So they're all exactly the same size as each other. I've just copied them across using the array copy tool. I've specified a particular distance in between each one of those. And the idea here is we're going to cut a pocket using the inlay toolpath. Now I'm not using the pocket toolpath because I need to create the female part of this to slot into, and the idea is I'm going to cut into MDF. I'm going to paint it up using chalk paint, and then that piece will slot into these pockets, and the idea is that you write the name of what's in the glass, for example IPAs, stouts, whatever, and the idea of the chalk paint is that we can rub it out and change it up. So this requires me to use the inlay toolpath, which I'll come on to in a moment. You can see we have these 2 circles here. Now I'm going to add in a cabinet handle here. So I've measured out the distance between the 2 holes, and it's roughly, well, the packet tells me that it's 96 millimeters, which is the equivalent of 3.7795 inches. However, I just want to test that to ensure that my handle is going to fit perfectly, and that my hole positions are spaced exactly as they need to. Okay, so that's pretty much this, which leads me to talk about the test file, and this is the one that you need to cut first. So if we go back and open an existing file, we're going to look at the inlay and test. So I've named the files with a number in front of the name, and this is just to tell you which one to cut first. So you want to cut this one first. It's important we do that. So if we open that up, we can take a look at this. So this is a simple square piece of MDF, 8 inches by 8 inches, and it's a 1/4 inch thick. I've took the vectors for the chalk boards or the chalk pocket boards that we've got from the beer flight file. I've brought them into here. I've also brought the circle. If I just go over to the toolpath tab and just undraw that so you can see those better. Got the circle here as well for the pint glass, and then we've got the 2 circles that represent the distance of the holes for the handle that I plan to assemble into the beer flight to act as a handle holder. Okay, so going over to the toolpath. So the first thing we're going to do is we're going to look at cutting out our little chalkboards, and we're going to use the Inlay toolpath, which is this one right here. So if we double click on that, I've chosen the male inlay, the straight insert, and we're going to cut all the way through, and the tool I'm going to use is a very small end mill, okay, 0.115. And that's pretty much it. So if I just close out and just switch that on, but if we switch on the solid preview, and if I just zoom in here, you'll see what happens is it actually comes over this corner. And the reason why we're using the Inlay toolpath is to ensure that the 2 parts can fit together. So this is the male part, and that's going to fit inside of the female inlay, which if we just switch over to the toolpath tab, and if I just bind this here and we'll put that into the solid preview, you'll see that we also have this tool curve in here, because obviously we can't get into the corners, and because we want to create an inlay, that's why we're going to have these curved corners because of the radius of our tool. So when you're doing straight inlays like this, you don't want to use a pocket and a profile toolpath. No, you don't want to do that. You want to look at using the Inlay toolpath, use the male appropriate to the male file and the female appropriate to the female file. Right then, so going back to our test, so we'd cut that out and that would be perfect. Right then, so they're handle holes. Okay, so again, I've just took that file and I'm just going to cut all the way through here. So we're using a pocket toolpath, cutting all the way through, using that 0.115 end mill, and once that's cut, I'm going to check that the handle screws fit inside and that they match up to the handle, and we can secure it all down perfectly. And if that's okay, great. If not, then I'm going to have to adjust the position of these 2 circles, whether I bring them close together or further apart. And so this really is only really kind of particular for my file and the handle that I'm using. If you wanted to use a handle, then you're going to have to do the same tests yourself, dependent on the distance between the 2 screw holes. And then we have this vector here, which is where we're going to test the glass. So here we're just doing a pocket toolpath, cut depth of 0.15 using just under a 1/4 inch end mill, and that's just going to do that, and then we'll check the fit of the glass in that pocket. Okay, so this is the file you want to cut first, purely so that we can get our cutouts of our chalkboards, and then what we'd do is we'd run the file for the beer flight itself. And the reason why we're cutting this second is all down to these inlays, because we may need to overcut this to test the fit of the chalkboards. So we have the chalkboards cut out, we're just going to check that they fit nice and snug inside the pockets here. Right then, so we'll get to that shortly. So the first toolpath we've got is a moulding toolpath. Okay, so we're using this vector here as our main drive rail, and we're using this vector here as our profile that's going to basically be swept along the rail of our moulding. Okay, toolpath position, I'm going to push that right to the top there, so we're going to have a gap below of just over 1/2 inch. I'm going to use an 1/8 inch ball nose here. I'm not going to bother with a clearance tool, I'm just going to go straight in with that. ensure that create sharp corners is checked so that we get the sharp corners and we don't get rounded corners. And then if we just close that off, and what we can do is we could look at previewing that. And that is what our part would look like. Okay, so at this stage I can see we've got some nice profile in there. Okay, looks good, so I'm good with that. Okay, so I'll just tile those windows. Secondly, we're going to go the glass pockets, assuming that the glass fits in the pocket on the test. Then we'd go ahead and run that toolpath, so the pocket toolpath cutting down to 0.15 using that 0.233 inch end mill tool. The inlay, okay, so double click on that. So here you can see we are using the female inlay, okay. We're just cutting down 0.1 in this case. We must make sure that we are using the exact same tool that we used to cut out the male part. We're going to cut this. Now, in the past I've done lots of cutouts using slot together parts or inlay parts, and you want to really create an allowance. Okay, so what usually works for me is negative 0.005 or negative 0.01. Okay, now you want to test this, so cut this value out first, and what that's going to do is essentially going to overcut it. So if I just zoom in over here, you can see it's overcutting past that vector by the negative 0.005. At this stage, once this is actually cut out, I'm going to take the cutouts that we did earlier, and we're just going to just place one of those in one of these pockets just to see how well it fits. If it fits okay, brilliant. If not, if it's too tight, it's not going in, then we'd need to come back in here and just increase this pocket allowance. So make sure that you remember to do this to ensure that it fits before you take everything off and then find out afterwards. Assuming that my handle holes are the correct distance, then would simply run this toolpath. So again, same as what you saw earlier, we're cutting it all the way through using a 0.115 end mill. Then we're going to go ahead and using a 60-degree half-inch V-bit, we're just going to run a profile pass on these circle vectors, and that's just going to give us a nice chamfer. It just looks nicer. There's no real other reason for this. So if we just go ahead and preview that, we can see how that will look. Okay, perfect. And then we've got a simple profile cutout whereby I've got tabs on the right hand and left hand side of my part. For obvious reasons, you can see the material that I'm using, I'm not going to have any room for tabs on the top and the bottom, so I'm making sure that I have enough tabs on the left and the right to really hold this down, whereby I have a tab thickness of 0.2. Okay, so we're using that 0.233, just a little bit less than 1/4 of an inch to cut this out, and would simply calculate that, preview what that one looks like, and that will simply cut the part out, and it should look something like this. Okay, perfect. So at this stage we're pretty much ready to go over to the lab, so let's take a look at how this turns out. Okay, so the first file we're cutting, as I mentioned earlier, is the inlays and the test file. And I'm using double-sided carpet tape to hold everything down. That way I can eliminate the need to add tabs to the chalkboard pieces, ensuring that we just have a nice perfect cutout and everything's going to be held down securely using that tape. And then for extra security, we're just going to hold the material down with screws. Perfect, so the glass fits. Now it's time to check the handle. So here I'm checking the handle holes are the correct distance apart from each other. As you can see, they are, so I needn't change the final file. Okay, so with the chalkboards cut out and everything's checked, it's time to cut out the beer flight. So whilst the Moulding Toolpath file is running, I'm cleaning up the mini chalkboards ready for painting, where I'm going to give it a few coats of chalkboard paint. Right, so back to the beer flight. Now that the Moulding Toolpath is complete, it's time to change the tool and run the next toolpath. Once I had finished machining the female inlays into the flight, it was time to test the fit. So taking a painted chalkboard, I pushed it into a slot and it fit perfectly. It wasn't too tight, nor was it too loose. If you find that your fit is too tight, then simply edit the file by increasing the negative allowance. But you must be careful that you don't increase it too much that it becomes too loose. So my overall advice here would be to run test cuts prior to cutting this out. So to finish, I'm using my favourite finish, which is the beeswax polish. And this is going to give it a shine. It's going to really lift out the beautiful grain in the wood. So one thing I didn't actually think about, and that is screwing the handles through the back of the flight. And to do that successfully, I needed to countersink the hole so that the screw head is sunken into the material, keeping the flight flat to the surface. Now you could turn this into a two-sided project, but it is simple enough to do this manually, as I have here using the handle holes as a guide to cut through. Now with all the chalkboards painted, it's time to slot them into their respective female pockets. Now if you wish you can glue them in, but the tight fit that I've got here is enough for the chalkboards to remain in place. They're not really going anywhere. Okay, so here we have the finished beer flights. You can see the handles are in place, and miniature chalkboards are displaying the different drinks that we've got on offer. My glass fits nicely into those pockets, and that's pretty much it. So if you want to have a go at creating your own version of your beer flight, then simply head over to the website to download the files from there. If you like this video, then give us a thumbs up, and if you've not yet subscribed to our channel, then please hit the subscribe button to get instant updates on the latest videos that we'll be releasing. So I think it's time to take this to the pub. See you later, happy making.